This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Edaena Salinas. This episode was recorded at KubeCon in Austin, Texas. KubeCon is the largest Kubernetes conference to date. Here, I talked with Nicole Hubbard. Nicole is an architect at WP Engine, where she focuses on building container-based infrastructure, automation, and helping teams deploy their applications. Prior to that, she worked at Rackspace on projects to power their cloud servers and on building software to automate the management of their data centers. Nicole has over 10 years of experience developing software and has a passion for building microservices that manage infrastructure. You're giving a talk here at KubeCon, and it's titled Scaling to 5,000 Unique Kubernetes Deployments and How You're Doing This. We're going to be talking about this today, but first, to give a bit of context, I want you to just describe what WP Engine is.
Yeah, so WP Engine is the leading WordPress digital experience platform. And we work with over 70,000 customers from 130 countries. And we power over 300,000 WordPress installations on our platform.
300,000?
300,000.
That's a lot. Okay.
And over 5% of the web visits at least one WP Engine powered site every day.
Mm-hmm. Okay, so this is really good because we get an idea of the scale of the product. Let's talk about managed WordPress hosting. Can you describe what this is?
So our co-founder, Jason Cohen, started WP Engine because back in the late 2000s, he was starting his own blog, and he was having a lot of difficulty running that. And so he actually started WP Engine as a simple hosting company. And then we've expanded on that to add additional offerings, things around security and making the platform highly performant. And then also, lastly, we added our support layer. So, and over the years, we've been building on that platform, adding things like analytics and personalization for our customers that help them power their digital experience.
WordPress is open source, wordpress.org. So I'm really curious, why are people willing to pay to have free software managed for them?
So WordPress is free, like a puppy is free. And, you get the puppy for free, but you still have to feed the puppy and take it to the vet and get shots. And WordPress has maintenance needs just like anything else. So just because you can download a zip file with PHP code doesn't mean that it scales, doesn't mean that it's secure by default, and there's a lot of maintenance around keeping it up to date, following security releases, and those types of things.
So when I start getting into a bit of the technical details of WP Engine, can you describe its architecture, sort of the main components at a higher level first?
Yeah, so our main components are, we have what we call, so we run on top of a virtual infrastructure.
Do you mean virtual machines?
Virtual machines, yes. And so in that virtual machine, we run everything we need to power the sites on that machine. So we have Nginx and Varnish and MySQL and all the storage for those machines there. We also have another offering that's our clusters, and it's very similar. The difference is we're able to run numerous webheads, and those run our Nginx and Apache processing to do the PHP processing and our Varnish workers. And then we actually pull the database and file storage off into separate servers that are then shared.
I see. And just before this, we were talking about how people are willing to pay to have their software managed. What are some of the problems WP Engine is solving? Again, just to give the context before we get into the migration, I want to understand, what is it solving? Security?
So companies turn to WP Engine to help with security, ensuring that their site's online. We have an award-winning support team that's available 24/7 to answer any questions that come up. And so those are the huge advantages that we offer.
Mm-hmm. What are some examples of applications and customers of WP Engine?
Yeah. So one of our customers is AMD's Developer Central website is hosted with us. They were facing some problems. Their CDN solution did not allow them to host files greater than 25 megabits, and they were constantly uploading files larger than 200 megabits, so they had to turn off their CDN, and this caused huge performance problems for them. So they worked to migrate to WP Engine to help solve those. Another one of our customers is the CMAs, so the Country Music Association, and they actually just recently had their large event a couple weeks back, and so we worked with them very closely to ensure that they were able to keep their site online during their award ceremony and keeping updates as the award winners were announced.
During your time as architect, one of the projects you've been focusing on is migrating to Kubernetes. And from what I understand and from what you just mentioned is it's built on top of virtual machines originally. Can you describe what this VM infrastructure consists of and what its purpose is?
Yeah, so the VM infrastructure consists of Nginx, Varnish, Apache, MySQL, and some other tools we run internally to help manage stuff. The first step in our migration into Kubernetes is to actually move the PHP processing off of the VMs and into the Kubernetes cluster.
Okay, but before we get to that, let's just focus a little bit on this virtual machine. So prior to the migration, what used to be the current state of things. So these virtual machines, what were they being used? You mentioned they host Apache and things like that, but...
Okay, yeah. So the virtual machines host all of our customer sites. Most of the sites live on one of the virtual machines unless they're in one of our clustered offerings.
What were the indicators that showed it's time to move to something else, or that maybe we don't want to stick around with this virtual machine infrastructure?
So one of the largest indicators that we saw with our VMs were around the utilization. We had very low utilization numbers as a whole when we took the aggregate for all of them, below 40%. So most of our virtual machines were sitting around very bored, but they would have occasional spikes where they would use all of the resources for each of the VMs, but those never seemed to occur at the same time. And so we thought there has to be a way we can get better utilization.
Is this an issue because you're saying 40% is being utilized and this costs money? Is that what the issue is? They're just sitting there?
Yeah, so we leverage AWS and Google for most of our infrastructure. And so we pay per core and memory that we provision. And for those to be sitting around not being utilized, it means we're spending money on infrastructure we don't need.
Okay. And was this the initial infrastructure, the virtual machines, or was there something prior to these virtual machines?
So we've always been on virtual machines. The way they've looked and the way they've been shaped has changed over the years, but they've always been very similar to what we have now.
And this project that you've been working on is, well, first of all, you at the beginning said there's 70,000 customers, I think, and you're working on moving 60,000 customers from virtual machines to Kubernetes. Did you decide to move particular customers first? Like, is there a step where you're saying, oh, it's better if we move X first and Y later?
So we have different levels of plans that we offer to our customers. So we have our personal plans, we have our premium plans, business plans, enterprise plans. So with the migration, we've started with our personal plans. These are generally people's personal blogs. So we'll roll that out to a small percentage of them first and validate no problems. And then as we continue in the rollout, we gradually start including the additional plans going up the stack to some of our larger customers.
Is it because they have specific characteristics with their usage of it, or?
A lot of times it's due to the risk profile that those sites are willing to tolerate. So before we wanted to keep the risk of our larger sites to a minimum as much as possible and ensure that we were able to catch any problems before we had major sites on it.
Mm-hmm. Okay. So here you're talking about moving just one low-risk tier of your real customers. Do you also do first like some test accounts and then just pretend you're migrating them? They're not real customers, but they look a lot like real customers.
So we have a bunch of internal accounts that we use. Some of these provide information for our support teams. We have public-facing sites that we host, one of those being our support garage. And so we actually are working to move those sites, and we'll complete those before we move customers. So we like to validate things with internal accounts before we ever put customers on them to ensure that we've caught the vast majority of any problems that are going to come up before it impacts the customer.
Okay. And this problem is, the reason we're talking about this is because it's not unique to WP Engine. There are lots of companies that go through these types of migrations. And like we're talking about moving a test accounts first, and then internal accounts, then real customers from a specific tier. And you're moving 60,000 of them out of 70,000 first. Are there customers with unique systems that will have to remain in the virtual machine infrastructure? Is there such a thing as, because of your type of page that you're hosting, you should always be in a virtual machine?
So for our initial rollout, we are going to continue to allow our enterprise customers to run on their VMs, mostly because they have larger workloads. They already have web servers that scale up and down based on the request that they have coming in, so we're going to continue with that for those customers. But for all the others who run on single node VMs, they'll be migrated into Kubernetes.
Okay. How big is a WordPress instance?
So it varies based on the installation of WordPress. So they can range from a couple megabytes all the way to gigabytes, depending on how many assets you have, how many plugins you've installed, how large your database is based on the posts you've made and the comments on your site, and all of that. So we have things ranging all the way from in the megabytes, 10, 20 megs, all the way up to numerous gigabytes.
Mm-hmm. And essentially, you're hosting a WordPress instance, right?
Yes.
Okay. About how many would you say you can serve from a single virtual machine?
Due to some of the limits that we've ran into around our security modeling, we're limited to only a couple hundred per machine on our virtual infrastructure that we use today.
Mm-hmm. Let's talk a bit more about this virtual machine infrastructure. What are the technical advantages that virtual machines provide plain server applications?
So we get to leverage the cloud, which is a huge advantage for us versus having to buy hardware. It allows us to scale up our infrastructure as customers purchase things and without, having server hardware cost.
Mm-hmm. Which was the initial motivation of why a lot of companies moved to this, right? Because they had their own hardware, or maybe they were not even creating a business because they couldn't afford the hardware and things like that, right?
Yeah.
Okay. Let's start talking a bit about this migration from virtual machines to Kubernetes. Do you know more detail about these cost benefits in addition to the utilization?
Yeah. So as we move into Kubernetes, our target is around a 70% CPU utilization. And so we're hoping that this is able to actually provide us a significant reduction in our infrastructure cost just from moving into Kubernetes.
Let's do a quick recap of what Kubernetes is, since this is what we're going to be talking about later on. Can you explain what Kubernetes is?
Yeah. So Kubernetes is a container orchestration tool. And so what that means is we're able to tell Kubernetes what the state of our cluster should be, and it will continuously run and ensure that things are in the correct state using reconciliation loops.
What do you mean by state?
So the state is which things should be running. Like, we want 3 instances of this application running in the cluster, and we want 10 instances of this application. And so we schedule those in, and it then coordinates that and spreads it across all the hardware.
So is the state about the cluster or the application? Because when I first heard the state, I understood like state running, state stopped, state restarting. It's
so in
not
this
about
case, it's mostly the state of the application and the desired state of it.
So by desired state, it would be, oh, now I need 4 instances of the application. And there used to be 1. Okay. One of the things you mentioned about Kubernetes is this an orchestration tool for containers. These are not virtual machines. Can you explain the difference between these two?
So when you start a virtual machine, you get a full operating system with all of the libraries and all of the software and packages that come in an operating system. So this gives you your init system, your logging via syslog in Linux, and then you've got SSH so that you're able to log in. And then after you have all your basic system processes, you then get to start running your processes on top of that. Whereas when you run inside of a container, you've got your operating system still that's running on the host node. But when you start the container, the only things that are actually starting are the application that you've defined in it. And it also provides an isolated environment for your application to run in. So say you have 2 applications that require different versions of Ruby with some of the same packages, but different versions of them and things like that, that can start to be a little bit of a pain to manage all on the same server. But
in a virtual machine.
In a virtual machine, yeah. But when you stick those into a container, they get their own isolated runtime environment, and it provides that isolation and allows them to have only exactly what they need.
Okay, so you said virtual machine, you're getting a full copy of the operating system. So it's essentially you're getting a new computer, to put it in simple terms.
Yeah.
And for containers, there's one OS that you specify called the host. And inside of it, you run multiple containers. And in each container, you specify the specific environment that you need for your application to run. For example, in the same machine, you can have a container running Python 2.7 and another one that's Python 3, right?
Correct.
Okay. Let's start talking about this migration from virtual machines to Kubernetes. What are some of the other disadvantages of having customers and virtual machines in addition to this cost-related problem? Is there anything else like about the OS and installing things?
So one of the other downsides that we face is as we continue to grow, the number of virtual machines we have continues to grow. For example, if you look at my talk, it says 5,000 unique instances, because when I submitted it, we had just over 5,000 virtual machines. Now we've actually surpassed 6,000 virtual machines, and that was in a short amount of time.
Yeah. Was it a couple of months? Or?
It was over,
Less than a year.
Less than a year.
Okay.
And as we continue to grow, when we have to deploy changes out to all of those servers, it takes longer and longer. And the management of those servers, so we have to manage, kernel upgrades, packages on the servers that have to be upgraded, and all of those things. And that provides a lot of overhead.
Mm-hmm. Is this growth attributed to new customers or just existing customers getting more views of their apps, or both?
So it's both. We have existing customers who continue to grow with us and upgrade to even larger plans that result in us building larger infrastructure for them and then adding new customers as well.
Okay. What would you say the main motivation of this migration was?
One of our main motivations was to simplify the management of our infrastructure.
Okay. First, I would have guessed the cost related, but that's a good answer.
The business is all about the cost savings. The engineering department's all about the simplification.
Yeah. So there's both benefits. If I talk to somebody in that area, they would say the cost, but simplifying the infrastructure is good too. You have the customers on WP Engine that you know you're going to move to Kubernetes. How do you structure this migration plan?
Yeah. So we've written some software that goes through and looks at some of the plugins that are on all of the installations.
What do you mean plugins?
So WordPress supports installing plugins. So these range from things that add simple functionality or potentially, say, a different commenting system instead of the built-in one, all the way to things like WooCommerce, which allows you to provide e-commerce through WordPress. So we look, one of the biggest risks is the plugins for the migration. So we look through the plugins that are installed on the sites, and we build out the migration plan for plugins that we know don't have any problems, and we'll work to transition those sites first. And then ones where we're unsure, we do some testing to make sure those plugins work, and then we slowly start moving those installations over until we're entirely confident on those plugins as well.
Okay. And the example that you mentioned of a plugin is, let's say I have my own site, it's a blog. It comes with a default way for people to write comments about my post. So a plugin would be a different way to write comments on my site.
Yeah.
Okay. Why did you mention these plugins are a risk?
So one of the largest parts in this migration is we're moving from Apache with mod PHP into PHP FPM. And in that migration, we lose the ability to use Htaccess files. And there are some plugins that heavily rely on that, as we found as we started this migration.
Mm-hmm. Can you explain what the Htaccess file is?
Yeah, so an Htaccess file allows you to set configuration values for Apache for the directory that you're in and the subdirectories for it. So one of the largest uses of it is to create rewrite rules. And these allow you to change the way that the URL gets sent to the backend to actually be processed. And then you can also do things like redirects and some other, configuration values.
Okay. So what you're saying is plugins provide this risk in this case because they're using a different version of PHP that relies on this?
It's because of the use of Htaccess.
The use of Htaccess.
Yeah.
Okay. So that's the first step of the migration plan, to analyze the website or blog and find this dependencies. Are the plugins considered dependencies?
Yeah, you could consider them dependencies.
So you find them and then flag them. If there's a plugin that you know cannot be migrated, then that's the first step.
That's the first step.
Okay. What comes next in the migration plan?
So during the actual transition, when we bring the site online in Kubernetes, what we do is we do a quick validation of the site before we transfer it to ensure the site is working as we expect. And then we transition the site to performing the PHP processing inside of Kubernetes. And then we do another validation to ensure that it's still responding the same way.
So this is once you've migrated it, you do a first validation, or where is the first validation happening?
So the first validation happens right before we migrate them. So we validate it, and then we migrate it, and then we check it then we migrate it, and then we validate that it's the same.
What are some of those checks from the first validation?
So for the most part, it's loading the homepage of the site and ensuring that it loads without any errors.
Okay, so you're checking the page loads without any errors before you've done anything to the page,
Correct.
right? Okay.
If something about the site's not working correctly already, we don't want to make that worse by migrating.
Okay. And then what did you say comes after this first validation?
So after that, we migrate them, and then we do that exact same validation step again to ensure that the site's loading correctly, being processed in Kubernetes.
Does this validation need to be automated, or is it enough?
Yeah, so we wrote automated scripts around it, and those provide the ability for us to move an entire virtual machine with a simple command.
Oh, okay. And what technology was used for those validation scripts?
So they are done in Python.
Oh, okay. Because first I thought this would be... there's these tools for testing websites where Selenium is one of them, and what you can do is it automatically launches the browser. You see it being launched and rendering the page and things like that.
Yeah, so those are really good tools. In this case, we're also using Go for this. We've written a internal tool that we use in Go that can actually go through and hit all the sites. And so the Python script actually wraps around that. So the Go script does the actual validation of the site.
Okay. In this validation, are you looking at network traces or
No,
response error codes?
We're specifically looking at response codes and the page, the actual body of the page to ensure it returned correctly.
Okay. And you don't look at the UI, what it looks like?
No, not in this case.
Okay. And for the body, it's the HTML body of the page. What are you validating there?
Specifically that it's loading correctly and that there's actually a body there.
Okay, cool. Let's see. What are the specific pieces that need to move from a VM to Kubernetes?
So in our first step into migrating into Kubernetes, the specific piece that we're migrating is the PHP processing. So we're moving from running Apache on the virtual machine to running PHP FPM with a Go wrapper around it in Kubernetes.
What did you say is the original PHP version? Or what was the name?
PHP FPM?
That's the new one, right?
That's the new one. Oh, the original was Apache.
Okay, and is there a significant difference between those two?
For the most part, no. The largest difference is the Htaccess file that I mentioned earlier.
Yeah.
But besides that, they both run PHP code almost the same way.
Okay.
So it's very little difference.
Okay. But why wouldn't you use the same one?
So with Apache, you have to configure configuration files for every site and point it to the directories. And then there's a lot of work we have to do, and we leverage AppArmor to provide security so that one site can't access the files of another site, and that we're able to restrict certain things that we need to restrict for security reasons. In the case of PHP FPM, we're able to start the workers for it in isolated namespaces and then mount the files for that request for the installation in real time as they come in, so that they only have access to those files, whereas that wasn't something we could easily accomplish with Apache.
Okay, so would you say PHP FPM has sort of wrapped all this notion of config options?
To an extent, yes. A lot of we wrote a lot of custom Go code that handles the responses as they come in before passing them to PHP FPM. And so since PHP FPM uses a fast CGI connection, we're able to forward the request to it over that.
What do you mean by fast CGI connection?
So fast CGI is the implementation, or the interface that you use to talk to it, to PHP FPM.
So just to recap, part of the motivation is that you're not using the same PHP is because of this config file and there's a lot of hacky work, it seems like, to secure it and make sure you don't talk to who you're not supposed to talk to. So it greatly simplifies the engineering process to move to PHP FPM.
Yep, exactly.
Okay. As part of this migration, when you're moving VMs to Kubernetes, how do you store customer-specific data? For example, is it volume mounts, or how does this work?
So what we've done for the initial stage is we leverage NFS to mount the files from the virtual machine into the Kubernetes pods.
Mm-hmm. Can you explain a little bit about NFS?
Yeah, so NFS provides you a way to share a file system across the network. And so it basically allows you to mount that file system and work with it just like you would any other set of files.
What have been some of the benefits of moving to Kubernetes? Because, like we mentioned, it's container orchestration tool, right?
Yeah. So beyond the simplification for management and cost savings, which are two huge benefits, we've also been able to start leveraging Kubernetes for our internal applications, so some of our internal microservices, and we get a lot of value there in the way that we're able to deploy things like monitoring services and logging services. We're able to get automated processes that configure those and read the logs and ship them to our logging destinations and things along those lines.
So it has increased the speed at which you deploy instances?
It does allow significantly faster deploys as well. And as we continue moving forward with building smaller microservices that are only responsible for one thing, that allows us to deploy those in a significantly faster and CI/CD way versus our older, more monolithic projects, which had to be deployed out to 6,000 VMs. And we're only able to deploy those once a week.
Okay. Do you have an idea of the cost comparison of running Kubernetes versus VMs?
So we're looking at somewhere between 40 and 50% cost savings as we continue to move into Kubernetes.
Between 40 and 50. Okay. Wow, that's pretty good. Have there been unexpected costs along the way of this migration, though? Like, yes, you get cost savings, but maybe there are some costs for doing this.
Not really. We've ran into a few things where we just kind of underestimated the amount of resources we would need, but nothing huge.
Does the customer know there's this migration happening? Maybe not in migration terms, but do they know something's going on?
So as part of our communication with our customers, we're giving them a heads up that over the, we're not telling them specifically when they're being moved, but we do tell them that coming up in the near future, your site will be transitioned to a new backend. But hopefully, if everything goes according to plan, it's completely non-impactful for the customer.
Mm-hmm. Yes, and what do you need to do to make sure it's non-impactful? For example, is it running at the same time in the VM as in Kubernetes? Or how do you guarantee that it'll be seamless to the customer?
So for the first week after we migrate a site into Kubernetes, we continue to run Apache on the VM. And if for any reason we're unable to make the request to Kubernetes, or if for any reason a customer starts reporting problems, we're able to switch them back to the Apache backend and to allow everything to process just like it was before.
Okay. So it sounds like at the beginning you're going to have both infrastructures fully running, right?
Just for a brief period of time.
Okay. Okay. Is that time determined based on if customers are reporting things, or is it set in stone, like for 1 month we're going to run both of them?
So the goal is it's 2 weeks, but if customers are reporting things, we'll obviously extend that.
Have there been migrations that have failed?
Not currently.
Okay.
We've only moved a handful. Well, we've moved our internal stuff and we've done some burn-in. And so we have a couple hundred sites that are running on it now, and we've not experienced any problems.
And even if some of them fail, well, you have this rollback plan, right?
Yeah.
Okay. So it's looking pretty good is what you're saying. That's good. And let's see. And the duration of a migration, does it depend on who you're migrating? Like how big the site is and things like that?
Since we're only moving the PHP processing and we're not actually having to move the files or anything along those lines, it actually, the size of the install doesn't matter in this case. So what happens is we spin up the infrastructure in Kubernetes to do the PHP processing for that set of installs. And then once that's running, we reconfigure those sites to then process there. And it's completely transparent to the request coming in, and everything's handled.
What are some of the technical aspects of container resource management in Kubernetes? Or do you have to manage? Is there resource management?
So Kubernetes allows you to control the resources of the individual containers. So you're able to limit the CPU and the RAM. And so we have limits that we've put in place for each of those to help keep those where we need them to be.
And is this automatically handled as you're scaling? Like does Kubernetes take care of that?
So Kubernetes won't automatically set your resources, but as long as you've set the limits, you can then use what's called a horizontal Pod Autoscaler, and that will be able to automatically scale your application up and down.
And do you specify there a range or something like that?
Yeah, you can give it a min and a max.
Okay. Let's talk a bit more about scaling and infrastructure. In the description of your talk, I saw that you mentioned most organizations only need to run a couple of deployments of their application in Kubernetes. What do you mean by this?
So what I mean is when you look at, a service that a company writes, they deploy it into Kubernetes and they usually run a production version, maybe a staging and a QA and a testing and some dev versions. But overall, you're not having to deploy the same application over 100 times. You're talking maybe 10 to 20 instances of it. Whereas in our case, we have to deploy it thousands.
I see. So this is because of the scale of WP Engine. So what you're saying in general, the majority is not this big scale.
Yeah, that, and you're able to you'll still have a large scale, but it's scaling one application really large. Whereas since we have to provide for, over 300,000 WordPress installs, we have numerous installations.
Okay. And in these cases, why is it straightforward to deploy to Kubernetes? Is it because it's just clicking a button or just a simple command?
So there's a lot of tools out there that help with deploying into Kubernetes. Helm is one of the big ones. And so Helm makes it really easy to deploy an instance of your application. And even when you need to deploy a staging version and a production or dev versions, it makes that process really easy for you. But when you start having to deploy even 100 of those, you're having to manage 100 different config files for each of those that you provide to Helm, and that starts to become a little cumbersome.
In Helm?
Inside Helm, yeah.
So then what do you do in that case? Is there another tool that you use or?
So what we did, we actually wrote a tool that we've made open source called Lostromos. And what it does is it leverages, Kubernetes has the concept of custom resources. And these allow us to define they represent any object that you want. And so we're able to define our virtual machines as a custom resource and then run a Helm deploy for each of those virtual machines.
Okay. And are you managing Kubernetes in your own infrastructure or through a cloud provider?
So we're leveraging cloud providers, specifically Google and AWS, and we're leveraging Google's GKE offering.
Mm-hmm. Okay, that's interesting because some of the people that I talk about, they're either AWS or Google or only Azure. Is there a reason why you're using two of them? Are you doing things in one of them that you don't get in the other one? Not really.
No, it's not that one of them provides us something the other doesn't. It's mostly about the availability of regions and what some of our customers demand from and want to have for their provider.
Okay. So one provider might be in other regions that the other one isn't.
Yeah.
But technically, they're very similar. It's just about this regions.
Correct.
Okay. What are the reasons why you would need to simultaneously deploy 5,000 unique instances of your applications?
So for our case, it's specifically around the scale we're at and being able to deploy and continue to migrate into Kubernetes. And so to make that process as simple as we could, it was easier not to completely overhaul all of our infrastructure in the first stage. But to continue to leverage the infrastructure we had in place and start pulling pieces out of it.
Mm-hmm. And what do you mean by unique instances? For example, is there a case where you're deploying simultaneously 5,000 not unique instances of your application?
Potentially. That would be something that could happen. In our case, what we're deploying is 5,000 instances of the same application. So it's our custom PHP processing application. And the only differences are some environment variables that tell the process where the files are located. So which of the VMs that it's responsible for serving.
So that's what the unique stands for in this case.
Yep.
Okay. What are some of the challenges of having an application that needs to be available worldwide?
So there's a lot of unique use cases that you start to run into when you look at worldwide availability of applications. One of them being not all countries have the same connectivity. And when the request is coming from China and it has to go all the way to the US to be served, that starts to add a lot of latency. So trying to remove as much of that latency as possible. It's actually one of our goals in future steps in our migration to Kubernetes is to actually try to remove as much of those network hops as we can. So by making the front edge of our network for all of our customers available worldwide in all of our data centers.
Okay. So what you're saying is to reduce that latency, is this when you have to use a CDN or
So
not?
CDNs can help with this. So as part of our offering, we do provide a CDN that customers can use, but not all of our customers leverage the CDN.
Do you know why? Is this because costs or?
Mostly, I think it's around cost.
Okay. Are there any other challenges of having a worldwide application? Well, those are the big ones.
Those are the big ones.
Yes, and I guess the other challenges would fall more under the customer's application, right? If it's worldwide, well, make sure you support different languages and your images don't have text in only one language and things like that, right?
Yeah, so a lot of those challenges fall onto our customers actually managing their sites. But since we don't have any control over what's actually on the sites, that's entirely up to the customer.
What is needed to manage Kubernetes at scale? The first thing you mentioned earlier is to not do it directly on Kubernetes, but find tools like Helm and things like that. Is there anything else that you need to manage it at scale?
Monitoring is extremely important. We leverage Prometheus within our Kubernetes clusters to be able to get metrics and data out and then generate alerts.
What sort of metrics do you get with Prometheus?
So it's able to talk to our applications and read any metrics that they're exposing to it. So anything from average request time to slowest request to number of requests, anything along those lines.
Mm-hmm. So these are things that you specify in the application?
Yeah, you get to specify them for your applications.
Okay. And, well, I guess, can you explain a bit of what Prometheus is? Is it a wrapper on Kubernetes or?
So Prometheus is part of the CNCF. It was the second project accepted by the CNCF, and it provides a tool that will go out and talk to your application and hit a metrics endpoint. So it scrapes the app and it saves all of those into a time series database that you're then able to query.
Okay. And do you use a separate tool to visualize this data?
Yeah, so we leverage Grafana to actually be able to query Prometheus and
you get
display graphs.
Okay.
Lots of pretty dashboards.
Yeah, I know. And how do you normally decide on which tools to use? Like, does it depend on what it costs? Is it open source or?
So we went the route of Grafana and Prometheus, specifically Prometheus, because it was able to handle the needs of the infrastructure that we have. We run into problems sometimes where some tools don't handle the scale that we're at, whereas Prometheus did not have that issue. We do like working with open source tools, but we're also willing to leverage commercial offerings if they meet our needs.
Okay. All right. Well, Nicole, thank you for coming on the show. It's been great talking to you.
Thanks for having me.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.